Over the weekend, I was spending some time thinking about what we know of energy, how we know about energy, and I was thinking about some of the things that we've talked about in terms of how science advances. Something like energy is not tangible; it's abstract. Unlike matter, which we could see, and so early scientists and philosophers were trying to come to grips with matter and trying to lump energy in with that. So over the weekend, I did a little bit of research into looking at the history of energy and our understanding of energy, and it was actually quite fascinating. So I decided that since this week we're going to be studying heat as energy and heat and temperature, that it might be actually interesting to do a little bit of a history lesson on the nature of our understanding of energy. And again, I want to put this into context. You, as a generation, are extremely lucky in that your phones have more computing power than the very first computer that IBM created, called Big Blue. So your phones, what you hold in your hands, used to be this take up the size of a room, a classroom, for computing power. And what it did was basically along the lines of what a calculator can do. It could do it faster and more repetitions of an algorithm, but it couldn't do much more than that. You have with the internet and television and radio, we disseminate and share information so quickly now that our advances in science are only slowed by our need to prove our results. And even those results are being proved faster and faster. We've seen with the COVID virus how quickly we can go from a test that takes 6 days to get results back to one that literally now can produce results in hours. So just in, there is an old phrase that's necessity is the mother of invention. And in this case, with our current situation with the COVID virus, we're seeing that happening where technology is advancing very quickly to try to meet the challenges of managing this contagion. So, looking at energy, the first recorded information I could find out was from 445 BC with Greek philosophers, and it was back to everything being made up of four elements. So they lumped everything in together, and of these four elements, earth, air, wind, and fire, they would typify everything on Earth, everything in the solar system, everything that they could see is to falling into one of these four, what they thought were states of matter, which were earth, air, wind, and fire. In 350 BC, you have again Greek philosophers expanding on this to where they added basic concepts to matter, and these four qualities that they created were dryness, wetness, hotness, and coldness. So they took those four states and they added those four qualities to help continue to typify what, in fact, matter was. And they lumped energy in with matter. It took almost 2,000 years for there to be any type of significant change in beliefs on matter. So, believe it or not, for 2,000 years, people believed that everything was earth, air, wind, and fire. But in 1617, Sir Francis Bacon, one of the members of the Enlightenment that I'm sure you've been studying with Miss BT, began to use observation and experimentation to demonstrate that heat is a form of motion. But people remained unconvinced, thinking that heat is still a type of fluid. So that's how they typified heat. Because heat would make ice melt and water would move, they considered it a fluid. So they considered it a form of water. It took almost or over 100 years for another advance to take place, and that was with Sir Gabriel Fahrenheit, and that's how we get Fahrenheit. He created an instrument using mercury and a thermometer to measure temperature, so that was a significant advance where we could now measure heat and measure temperature. And he established boiling point at 212 degrees Fahrenheit and freezing at 32 degrees Fahrenheit. Hasn't changed since 1721 with Sir Gabriel Fahrenheit. So there was another 20-year gap in terms of anything significant happening until 1942, when a Swedish astronomer, believe it or not, Anders Celsius, created a scale in which freezing was 0. So he created the centigrade scale, where boiling was 100 and freezing was at 0. And Celsius, again, we name things after people who discover them, and that is still true today. So Fahrenheit, who did his work in the early 1700s, and Celsius, who did them in the middle 1700s, it's still that way today. In 1798, a scientist named Benjamin Thompson, who later became Count Rumford in England. He was American born, but he lived in England and became a count. He began doing work on heat and friction. So he began to understand heat as something other than fluid. And his observations while working in a munitions factory showed that the tools working with creating large cannons generated heat. And so he concluded that friction could be an endless source of heat. And this finally put an end to the belief that heat was a fluid. Believe it or not, it was 1798 before they began looking at heat as something more than a fluid, which was established back in the, before the birth of Christ. So it was, I guess, back in 350 BC that heat was established as a fluid. In 1724, a French physicist named Nicolas Carnot established that heat moves from hot to cold, not cold to hot. So that is still something. So that was something that was established in 1824. Still fairly recent times in terms of the history of the Earth. We finally began to have some huge advances in the understanding of heat as energy around the middle 1800s. There was a British physicist named James Joule, and of course we measure things heat in joules. He began to understand that energy had many different forms. So he began to understand mechanical energy, thermal energy, and he began to finally associate heat as thermal energy. And he used a paddle wheel device to show that many different forms of energy could be converted into other forms of energy. We were still a long way from understanding the laws of the conservation of energy, but he's the first one who was actually able to show that we could convert mechanical energy into thermal energy, things like that. And that was really the first huge advancement that was made in terms of beginning to see energy as a property of matter. And then in 1906, we have a physicist named Walter Merst, who created another scale for energy, which was the absolute scale, which they called Kelvin. And at that point in the early 1900s, we were beginning to understand that energy and matter, in terms of atoms, electrons, that sort of thing, were intimately connected. And that they began to understand that it was the movement of electrons in some form or fashion that was actually the cause of energy and the movement of energy and different types of energy. So he, on the Kelvin scale, was the first one to suggest the concept of absolute zero, which was where we could get electrons to stop moving. Of course, at this point, these were all theoretical ideas. It was in, of course, the early 1900s and mid to late 1800s with the Industrial Revolution that we saw enormous advances in tools and things being developed that were able to move science very, very rapidly to the point where we have our understandings the way that we do today. But at this point, we were talking about rapid but incremental understanding to where we are today, and it was early astronomers, early physicists of the 19th century that actually advanced these ideas the farthest. There are still things that we're learning about energy, and a lot of it has to do with how energy performs in nature. So one of the things that I found that was quite interesting was a discovery that was made in 2003 by an Israeli scientist who studied insects, and he discovered that wasps actually can use energy to create an internal air conditioning system within their body, which allows them to function during extreme heats in the deserts. It's like here in Arizona, Israel is quite hot in the summer times, and they were actually using energy to stay cool, much like we do with air conditioning. So anyway, today is just basically a little science history day. I want you to use your time to catch up today. Over the weekend, when I was looking at your work, there's an awful lot of discussion questions that haven't been answered and other things. If you have completed everything, bravo, congratulations, and thank you. I really appreciate it. If you haven't used this day to catch up, we are going to be studying heat and heat energy a lot this week. So it'll gear you up and make you ready to be able to stay on top of things for this week. All right. Glad to see you. It is Monday, April 6th, and all things EQ, remember to take care of yourselves, pace yourselves, create an environment that's good for you to work in, and don't give up. Bye.